Hello everyone, today we'll be talking about Leetcode 221 Maximal Squares. So this problem says, given a 2D binary matrix filled with zeros and ones, find the largest square containing only ones and return its area. Note that this is the largest square and not the largest rectangle. And here's an example. So they gave you the matrix, and obviously here the maximum squared area would be 4 because the maximum side length is 2. And let me switch over to my whiteboard here. And as I can see, I marked out the squares that can be potentially candidates for the maximum. I ended up choosing the red, but you could have chosen the blue as well. Okay, so the solution for this problem is going to be a DP solution. You want to construct a 2D array that stores the maximum side lengths that's seen so far in the dataset. And by dataset, I mean the matrix array that they gave you. Okay, so to get the maximum side length, you have to take the min value of the surrounding squares. By squares, I mean the surrounding cells in the DP array, and then you want to add 1 to it to get the new max side length. And at the end, you square the max side length and return the answer. All right, I'm going to show you what I mean by that solution. Okay, so here is the DP array I was talking about, and I instantiated it to be 1 unit wider and 1 unit taller. So when I'm at 1, 1, it doesn't go out of bounds. So I have these boundary cases here. All right, so what I did here is I started taking in values from the matrix, and if it was a 1, I would min all 3 surrounding cells on the matrix. And as you can see here, these 3 right now is 0. So then I add 1 to obtain the new maximum side length. So I basically continue that for the whole array. And then once you get to this step right here, which is this one in that array, you'll find that the min is all 1s. So then you add 1, and then you get the 2. And then you would do the same for this, and you would get another 2. At the end, you would find that 2 is the longest side length, and then you would square the 2, which will get you the answer of 4 at the end. Okay, let's go to Leetcode and code this out. All right. Starting at the beginning, I'm going to actually put a fail-safe case so it doesn't keep going. And that's basically if the matrix is null or the matrix's length is basically 0. So then you just return 0. Nothing happens in that situation. Okay. Now you want to set the size of your DP array, and I'm just going to use M for the height and then N for the column. M will be matrix.length plus 1, just matrix.length, and then N will be matrix at 0.length. And then my DP array will be a size of M plus 1 and then N plus 1. Okay, so now what I need to do is to traverse the array and then store its values in. And I'm going to use I and j for the indices. I smaller or equal to n, and then I plus plus, or int j is at 0, j is smaller or equal to n, j plus plus. Okay, so in this loop is the important part of this program. We need to calculate the maximum side length here. And here I'm actually going to use a variable before it says max length, so we don't have to traverse the array again once we finish storing the values. And in this case, max length can be 0 because that's actually the minimum length that you can get. So it doesn't have to be integer dot min value. Okay, And inside the traverse, we only need to do an operation on the DP array if the matrix is the value in the at ij in the matrix is 1. And remember here, I and j should actually start at 1 because we want to skip this and that. Okay, so because they started at 1, now matrix the indices at matrix will have to be subtracted by 1 to avoid an array out of bounds runtime error. And right here, we're just going to say if it is equal to the char 1. And if it is, then we'll do an operation on dpi at j will be equal to the surrounding cells, one of which is I minus 1 and then j. And we need to do on the other two sides. So I minus 1, j minus 1, and I j minus 1. Okay, so what this segment does is it takes the surrounding cells, which is these, and then it takes the min, so you can add 1 to get your side length. And then all that's left to do here is to add the 1. Then what you need to do is to max the max length along the way, so you don't have to traverse it again, and it'll just max with the DPI at j. Okay, so what happens if it's not a 1? Then what you need to do is you just need to put the 0 in. That's pretty simple because it's only going to be 0. And once this is finished, all that you need to do is to square your max length and return the answer. And it's probably best to just write it out. It's not too hard. So now the program is done. I'm just gonna print out the 2D array here so you guys can see this. Alright. Okay, so I'm nearly done here. Okay, so I'm just gonna run to see if it works, and I'll show you the array. Okay, alright, so here's the array. As you can tell, 2 and 2 is obviously the max length, and it returned the square of that. And that's how the array looks. I'm gonna comment it out so I can save time on the submission, and let's see if it works. Alright, and it passes. And let's talk about the time complexity here. Basically, we're just traversing through the DP array to fill it out, which means the time complexity is O of m times n. One way to optimize this program is the memory. Right now, it's using a 2D array. If you want to save more space, then you can actually modify this into a 1D array, and then you have to keep track of a pre value here to compare in these statements. Otherwise, the 2D array is probably more simple to use and more common, and that's how you solve Maximal Squared. Right, thanks for listening, and I hope you like and enjoy this, like and subscribe this video. If you want to check out my other videos, go to my channel page, or you can check out more dynamic programming videos by going to the playlist that I made.